Hi, welcome to this short introduction to Grails integration with automated business logic. Let's start with defining what automated business logic is. Then we'll give a brief overview of the process, then show the demo. So automated business logic automatically enforces your business rules when you commit transactions. In particular, there are multi-table derivations like sums and counts, like the customer balance is the sum of the unpaid order totals, and these can chain between tables in an automated way. The next piece is automated constraints. These are not limited to single fields. They're multi-field and in fact multi-table, and they're often used to constrain derivation results. Actions are provided, so you can invoke operations like auditing or sending mail with a single rule. We're going to show a demo here that's very short so you can understand it in just a few minutes, but the point that you should take away is that these kinds of rules can scale to very complex sorts of use cases, such as a bill of materials explosion expressed in 2 or 3 rules. And finally, you'll see that the business logic is very easy to integrate into Grails by virtue of our demonstration. So how do you use it? There's basically 2 pieces as shown in this diagram here. First, you use Grails itself to define your domains and run some wizards to build the controllers. That's shown in another video that's provided, but if you're already familiar with Grails, you don't need to see that. Secondly, and this is where automated business logic comes in, you might use STS to define some rules. That builds what we call business logic components, which are groovy classes that enforce your logic. So how does it work? When the Grails application runs, it invokes the GORM layer, which is a layer that simplifies Hibernate. Hibernate publishes events that the business logic engine plugs into to find and invoke your rules in a proper and efficient order. You can read more about that on our homepage, but for now we'll just sort of presume that that works fine. So what is the application we're going to have a look at? It's the world's most familiar application. We have customers. Customers have a set of orders. Each order consists of line items, that's things you buy, and products are the things that are in the order. So what we're going to do is make sure that the objective, the requirement, the business requirement, is to make sure that the balance, which is the roll-up of the line items to the order, doesn't exceed the customer's credit limit. More formally, we can express that with these 5 rules. So let's just understand these. We could define a constraint that says the balance must be less than the credit limit. And then the balance is defined as the sum of the order totals where they're not paid for. Where the order total, you see how these chain, where the order total is the sum of the line items amount. Line items amount is the quantity times the parts price. And where the parts price is obtained only initially from the corresponding product. So that's what we might write on our napkin. Well, let's now see how we define those in automated business logic. So here's STS. As we said earlier, this is a Grails project. So there's your domain with customer order item and so forth. And what we've done is defined here some groovy classes under source. And you can see that there's a correspondence between customer and so forth. So these are the logic files that correspond to the domain classes, enforcing the rules that you defined there. Here are the rules. So let's just show this over a bit so we can see it. So here was our spec, if you will. The first constraint was the balance less than the credit limit. We actually got a little bit more fancy here so we could demonstrate that you can define rules either with simply an annotation, or you can define them as a method so that you can introduce if-then-else logic. So this says that the customer is preferred, you can read the rule, then if that condition is not met, then we signal an error, and if the system detects this condition at runtime, it'll throw an exception, which can be handled by your client code. Here's the balance rule that says the definition of how to derive the customer's balance. And as you can see, this is actually entered directly. So backing up, what we understand that is, we have a class corresponding to each domain object. That class has methods in it that are identified by these annotations as having rules in them. Here's a constraint rule. Here's a sum derivation rule. And The runtime business logic engine will find these classes at runtime, understand their dependencies so as to execute their logic in a proper and efficient order. Moving on with our example, we see that the purchase order has a rule that says it's the sum of the line items amount. Well, it's the same story here. And find the line item price is obtained by these two rules. It's simply the price times the quantity. Here we're expressing the rule in the annotation, where the product's price is copied from the product. This is a rule of which you've got a choice. What this is saying is if you buy something on a Monday and the price changes on a Tuesday, orders placed on a Monday don't reflect the new price. You have a choice. Of course, you could have just said here, line item dot product price, and that would have propagated any changes. But that's a business decision, not a restriction, just a choice you need to make with the product. So that's literally all you do define these rules. You can look on our webpage, on our home page. You'll see that we took our best shot at defining this in Java. This was 500 lines of code. That's kind of amazing. Part of the reason is that when you define these rules, you may be thinking in terms of placing an order. In fact, these rules ought to be able to handle all of these various use cases. Placing orders, deleting order item, changing the quantity of an order item, and so forth. It's actually hard to think of all the use cases that should be, over which these rules should be reused, because that's a manual, error-prone process. Automated business logic, however, makes it automatic, so all of these use cases are automatically enforced by those simple rules. Now let's take a look at running the application. All right, at this point we've started up Grails. We've built our controllers as shown in the other video. We might look at the customer and find out that the balance of Alpha and Sons is 85. If we drill down into the line items and edit one, should change the quantity, say, to 10. Business logic just ran. And we see now that the balance has changed to 310. That's completely automatic, and as we said earlier, it would have run regardless of which kind of transaction you might have executed. So we invite you to have a download of this product. There's much more information on the home page explaining exactly how the engine works, and we'd love to hear from you. Thanks very much.